So in this session, we will discuss a structure question related to topic rate and order of the reaction. So in this question, we have iodine and propanol react in the presence of aqueous acid as follows. So the overall equation is given and the rate equation is also given. To determine the rate of the reaction, propanol is reacted with iodine in the presence of aqueous hydrochloric acid at a constant temperature. Samples are withdrawn at a time and quenched with sodium hydrogen carbonate. Why we quench with sodium hydrogen carbonate? Because acid, which is used as a catalyst here, is being neutralized by this sodium hydrogen carbonate, so the concentration or the reaction will not further proceed as the acid will be used up. And then the iodine remaining is titrated with a standard sodium thiosulfate solution. So when we say standard, it means we know the concentration. The rate equation for the reaction is there. As you can see, rate is equal to K times the concentration of propanol, concentration of hydrogen ion, and concentration of iodine molecule. The graph of I2, the concentration of iodine, against the time with a straight line, shows that the order is the order of the reaction with respect to iodine is 0. Explain why propanol and hydrogen ion must be in large axis in this experiment in order to give a straight line. So why we should have, when we are finding the effect of concentration of iodine on the rate, the propanol and the hydrogen ion concentration should be too much axis, like more than enough. So what could be a reason why we should have like too much iodine or more than enough iodine? So because we were finding the effect of why we should have excess of hydrogen and propanol, because we are finding the effect of concentration of or change in concentration of iodine on the rate. So we want hydrogen ion and propanol ion to be, their concentration should not change. And how we can make sure their concentration will not change? So we take them in axis. So why propanol and hydrogen ions in axis, so that their concentrations remain unchanged. So they are too much. So if too much is there, even a small quantity is used from a large or bulk, then we can say there is negligible change. Like example, if I say I have example 100,000 molecules of hydrogen ion and propanol, and out of 100,000 only 2 or 3 molecules react. So when we compare the change, it is a negligible change. So when we have something in a bulk, a small quantity is used, so we can consider that it is negligible. That's one point. And the second thing, so the change in concentration of iodine or the effect on the rate due to change in concentration of iodine can be identified. Is it clear? This part, A1.
Yes, sir.
So whenever we want to find the effect of one reagent, we kept the other reagent in axis or more than enough, so their change in concentration does not have any effect on the rate. What further experiment could be done to show that order of a reaction with respect to propanol is 1 and state the effect on this change on the graph? So how we can make sure or how we can identify that it is first order with respect to propanol? So we can double the concentration of propanol, or we can change the concentration of propanol. And because it is a first order, so we can double the concentration of propanol, and then we can sketch a graph or draw a graph between rate and concentration. It will be a straight line. So that confirms that it is first order with respect to propanol. So if we sketch a graph for concentration of propanol and the rate, so that will be a straight line which is starting from origin. Is it clear?
Sir, could it also be a concentration time graph?
Yeah, it can be a concentration time graph as well.
Okay.
Then it should have a constant half-life. The change in concentration for with respect to time, because it's a first order, for first order it should have a constant half-life. So slope or gradient, or you can also mention, if we plot a graph, it will be a straight line and both increase with the same factor. You can mention about concentration graph as well. Explain why the minimum number of steps in the mechanism is 2. So why the minimum number of, basically why it is simply, they are saying why it is not a one step reaction, why it is having multiple steps, 2, or it can be more, but here in this example this is having 2. So as you can see here, the reactants, the original reactants are not involved in the rate determining step, because the rate expression according to overall equation, if it was a one step reaction, then what should be the rate expression, rate equation? Rate is equals to K times the concentration of propanol and the concentration of iodine. This should be the equation if it was a one step reaction. But as you can see that the equation does not have the original reactants, so this confirms that it is not the one step reaction, it is a multiple step reaction. So we can say that iodine is not involved in a rate determining step, as we can see in the rate equation, and hydrogen is involved in a rate determining step. So and catalyst can be regenerated, because hydrogen ion, as you can see in the, hydrogen ion is not the reactant, but hydrogen ion is involved in the rate determining step. If hydrogen ion is involved in the rate determining step, because it is a catalyst, so it must be regenerated, because catalyst is a substance which is chemically unchanged, or it is regenerated when the chemical reaction ends. So how we can make sure that it is a multiple step reaction? So first thing, hydrogen is involved in the rate determining step, and hydrogen must be reproduced or regenerate because it is a catalyst, so it shows that it will be a multiple step reaction. Is it clear?
Yes, sir.
So why the minimum number of step? So here hydrogen is involved in the rate determining step, which is a catalyst, and hydrogen must be reproduced or regenerate for this reaction. So that's why first hydrogen is used up, like reacted, and then hydrogen must be regenerated as it is a catalyst. So it will be two-step reaction or multiple step reaction, not a single step. Then sodium hydrogen carbonate stop the reaction by neutralizing the acid catalyst. Write an ionic equation for reaction between sodium hydrogen carbonate and the acid. So acid means the hydrogen ion is there, H plus ion is there, and sodium hydrogen and we need an ionic equation. So sodium hydrogen carbonate, basically if I write the full equation, but we don't have to write a full equation, it's only 1 mark. But first I'm writing a full equation that if HCl, which is aqueous, reacting with sodium hydrogen carbonate, because when acid react with carbonate it will give salt, water and carbon dioxide. So same thing for hydrogen carbonate, it will form sodium chloride aqueous, it will produce water in a liquid state and there will be carbon dioxide in a gaseous state. So we cancel the common ions. Cl is common ion in aqueous, and this also aqueous. So what we are left with, the hydrogen ions reacted with hydrogen carbonate ions result in a formation of water and carbon dioxide. So this is the basically ionic equation for this reaction. So this is having 1 mark. We don't have to show the full equation. I just write the full equation to work out the ionic equation. The next part, sodium hydroxide cannot be used for neutralization because under very alkaline condition, a reaction occur between propanol and iodine. So write equation for this. This is related to organic part, organic chemistry. So that we will do later because this part is related to organic chemistry. We only completed the first topic, which is about kinetics. Question 2. A student investigated the reaction between iodine and propanol in acidic condition. So you always find a similar question. Sometimes we have to sketch a graph from the concentration. So 50 cm cube of 0.02 mole per dm cube iodine solution is measured in the flask. 25 cm cube and of propanol and 25 cm cube of sulfuric acid is added. 10 cm cube of sample of 0.5 mole per dm cube sodium hydrogen carbonate placed in a separate conical flask. The mixture of propanol and sulfuric acid was added to iodine and a clock started. After 2 minutes interval, 10 cm cube of sample is removed. Like we take out the sample uh, and transfer to a container which is having a sodium hydrogen carbonate that is used to as a quenching agent. The content of this flask then titrated with sodium thiosulfate. Explain the purpose of adding the reaction mixture to sodium hydrogen carbonate.
To neutralize the acid catalyst.
Yeah, to neutralize the acid catalyst and to stop the reaction. To quench the reaction, to stop the reaction, to slow down the reaction, you can mention, so that the acid does not react with thiosulfate as well, but otherwise the acid can also react with thiosulfate. So 1 mark you will mention to quench, to neutralize the acid, to remove the acid, and the second mark is for mentioning so that the acid does not react with thiosulfate or propanol in the mixture. Stop reaction, slow down reaction, or quench reaction, or neutralize the acid. That's one thing. And then, so acid does not react with thiosulfate or because the original reactant is propanol, so it will not react with propanol as well. The next part, what indicator should be used in titration? Because iodine thiosulfate titration, so we use starch as a indicator. That is there in AS, the iodine thiosulfate titration, so we use starch as an indicator. Because when iodine is present in the solution, in the presence of starch, it is blue-black. And when it react with thiosulfate, so it turn into iodide ion, so it will change into colorless. So we can identify this sharp color change. If starch is not used, then iodine, if it is a concentrated solution, it will be brown in color, and if it is dilute solution, it will be yellow in color. So when ion is formed by reacting with thiosulfate, so it will turn into colorless. But this color change, because yellow color disappear, it's a light color, so it will be difficult to identify compared to a dark color, which is blue-black, changes to colorless, so it will be easy to identify. That's why we use starch as an indicator. So in the presence of starch, it will show a color change. In this experiment, the concentration of iodine is 0.02 and the concentration of propanol and sulfuric acid both are 1. Why iodine solution use is much less concentrated than propanol and sulfuric acid? So it's the same reason like why we have excess of propanol and sulfuric acid. So their concentration does not change and the rate is, because we are finding the effect of concentration of iodine or change in concentration of iodine on the rate of reaction. So we can say, so propanol concentration or iodine acid concentration is virtually constant. So therefore rate would only depends on change in concentration of iodine. So why we are using excess of these two? So the concentration of propanol and sulfuric acid or acid catalyst remain virtually constant. A small amount will be there, change will be there, but virtually it is constant because it's too much excess, and the concentration, the change in concentration of iodine have effect on the rate. Then the shape of the graph obtained from the result of the experiment is shown below. Volume of thiosulfate, and so this is about volume of thiosulfate, but as you can see, because what happened, the thiosulfate, sodium thiosulfate is reacting with iodine. So as you can see in the beginning, we need greater amount of thiosulfate, but with the passage of time, as we are taking out the sample, we need small quantity of thiosulfate. So why amount of thiosulfate needed is decreasing? Because amount of iodine is also decreasing. In the beginning, you will have more iodine, but as the passage of time, amount of iodine is decreasing. So that's why you need a small quantity of thiosulfate as well. So use the graph, deduce the order of reaction with respect to iodine and explain your reasoning. So if we have a volume change in volume and time or concentration and time, a straight line graph, so what we can say first, what kind of order, what is the order of this reaction?
0.
So this is zero order reaction. And the reason is that because the slope is constant or rate of change of iodine concentration does not change with time. So one mark is for mentioning this is a zero order reaction. And what is the reason for that? The slope is constant or gradient is constant, which shows rate is constant or we can say the change in concentration of iodine with respect to time remain same. That's why it is a zero order reaction. The next part, the solution used in the experiment could be measured using either a measuring cylinder or a pipette. Give one advantage that we did in O levels, that one advantage of using a measuring cylinder, it will be fast, like we can transfer it quickly, and one advantage of using a pipette, it can measure the volume accurately as possible. So pipette will be more accurate, and measuring cylinder, the solution can be transferred quickly. In part F, in a further investigation, different volumes of sulfuric acid, propanol, iodine were mixed together, and time taken for a mixture to go colorless was measured. The experiment was repeated. Results are shown, as you can see. Uh, the concentration, the volume. Basically, we are keeping concentration same, and we are changing the volume. So when we change the volume, basically the concentration also changes in the solution. The overall, like original concentration of sulfuric acid is 2 mole per dm cube, propanol is 2, and water is there, amount is there. But when we take the total volume, as you can see, the total volume of the solution is 28. So with respect to 28, the amount of sulfuric acid is 20, propanol is 8. So that it means that the volume will be proportional to concentration in the mixture. So in the mixture, the one which will have a greater volume will have a greater concentration. Explain why water is added in experiment 2 and 3. So why we add water in experiment 2 and experiment 3? Basically, to keep the total volume constant and to make the concentration proportional to volume of the reactant. So the total volume of solution used in experiments remain constant same, and the concentration of reactant or reagent proportional to volume used in the mixture. Is it clear?
Yes, sir.
So basically what we did, we make the total volume same. Otherwise, like if you are not using a water, without a water, this total volume will be 18. And without a water, this total volume will be 24. And this will be 28. So the three solutions in experiments will have a different volumes. So if they have different volumes, we cannot identify the actual rate or effect of the change in concentration or rate. So what we did, we make the total volume same. So when we make the total volume same for each experiment, the one which is in a greater proportion, like greater volume in the mixture, that will have a greater concentration in the mixture. Like here we have 10, 20. So it means the solution will have higher concentration than experiment 2. Show that uh, show how you would use the data to deduce the order of reaction with respect to propanol and hydrogen and write the rate equation. So how we can use this data? So the first one, we are using 20 cm cube of propanol, and we are using the total volume of the solution is 32. Why the total volume is 32? Because iodine is also added. So if iodine is added, the total volume should be 32, because 20 plus 8 plus 4, so it will be 32. Now, how we can work out the rate of this reaction, or the equation which in the rate equation? So if we are using this 20, and now what we did, we took 10 cm cube. So what happened to rate? Originally the rate was 8 exponent minus 5, then it become half of it, because here what we did, the volume is half, the rate is also half. So what we can conclude about the order of this reaction with respect to acid or hydrogen ion? So if one is half, the other is also half, so we can say that rate will be equal to the K times concentration of hydrogen or acid raised to power 1. And when
Sir,
we,
so the water will have no effect on the rate?
water is having, if it's, water is not the reagent here, water is only used for diluting the mixture, so that the total volume will remain same. So water is actually diluting the mixture. It's not as a reactant it is used, it's just diluting the mixture and making sure that the total volume of all the experiments will remain same. And when we check experiment 1, because if we compare experiment 1 with 3, so this is 8, this become 4. If this is becoming 4, what happened experiment 1 and 3, that so it means it divided by 2, all the rate also divided by 2. So what it confirmed? It confirmed this is first order with respect to propanol. Is it clear?
Yes, sir.
And iodine, as we know, it is zero order with respect to iodine. So I'll write I 0. So this will be the rate equation, and the explanation you will mention, in explanation you will mention when we compare the first two experiment 1 and 2, the volume is half, so the concentration is also half, and the rate also half, so it means it is first order with respect to hydrogen. And same way we will compare experiment 1 with experiment 3. So the volume is half, it means the total concentration is also half, and it shows the rate is also half, so it again shows it is first order with respect to propanol. Another question, this question is about the kinetics of the reaction between bromobutane and aqueous hydrogen iodide, aqueous hydroxide ions. The results of an experiment to find the initial rate are shown. So we use zero point 0.1 mole per dm cube of bromoethane, and we use hydroxide ion of 0.15. The rate was 1.54 into 10 power minus 6. So we have to calculate the value of the K and include the units. So and the rate equation is given. So if the equation is given, we just have to substitute the value. The value of the rate is 1.54 into 10 power minus 6. The K is unknown. The concentration of bromoethane, that is zero point 0.1, and the concentration of hydroxide ion, that is 0.15. This is multiplied, other side will divide, for 1.54 into 10 power minus 6 divided by 0.1 into 0.15. So this will give us the value of the K, which is 1.03 into 10 to the power minus 4. Then what about the unit? How we can work? It's overall it is a second order, but we can work out the unit for K. As we know, uh, the unit of the rate is mole per dm cube second. Concentration is mole per dm cube. Other concentration will be mole per dm cube. This mole per dm cube cancel with mole per dm cube. So this is 1 over second is equals to K mole per dm cube. Dm cube is divided, other side will be multiplied, so it will be dm cube 3. Mole is multiplied, other side will divide, so it will be mole and second. Or we can say dm cube 3 mole inverse second inverse. So that will be the unit of K. Is it clear this part?
Yes, sir.
The concentration, calculate the initial rate if the concentration of both reactants were changed to 0.02. So what happened? Now we already have the value of the K. So we have the value of the rate is equals to K times the concentration of both reactant, which is bromoethane, and the concentration of hydroxide. So we double the concentration we make the same concentration 0.02 for both reactants 0.02, and the value of the K we already worked out, it was 1.03 to 10 to the minus 4, the previous answer. So we multiply them all, we'll get the initial rate, which will come out as 4.1 into 10 to the power minus 8. And because it is a rate, the unit of rate is mole per dm cube second. K can have different units, but the rate will always have this unit. State the order of this reaction. So this is which order reaction? The overall.
Second.
So it is a second order reaction overall, because first order with respect to bromoethane and first order with respect to OH. So overall it will be a second order. The mechanism for this reaction, as you can see, both reagents are involved. In the rate equation, both reagents are involved. So what it will be? It will be Sn1 or
Sn2.
Sn2.
Yeah.
So we have to basically show Sn2 mechanism. What happened? The bond breaking when bond forming will take place at the same time. So first we draw bromo ethane. This is bromoethane. The attacking nucleophile OH will be there. This will be partial positive and negative. This will attack on carbon. So the bond breaking and bond forming will take place at the same time. So dotted line should be there. So it will form a transition state is there, intermediate is there, which will have a negative, and then bromine will break the bond, OH will form a bond. So as a result, CH3, H, H, OH. Is it clear? Plus Br.
Yes, sir.
So this is the mechanism for this. But we don't have to draw full. They mention draw the transition state. So what we have to draw? We have to draw only this part. But because as like a revision, I mentioned the whole mechanism so that you can recall the idea for Sn2 reaction. But you don't have to show all, you just have to show the transition state. Then the rate constant for the reaction between bromoethane and hydroxide ion was determined at 5 different temperatures. As you can see, the value of the temperature is given 333. So we'll take a reciprocal here. We have to complete the missing table, the values in the table. So what about 1 divided by 333? So it will be 3 exponent minus 3. But because you can see all are in 3 significant figures, so even it's 3 exponent minus 3, but I will write as 3.00 into 10 to the power minus 3. Then we take the rate is given ln k. How to take in scientific calculator? You can see this ln function. Press shift because there's a button E on that. It is ln, or you have a button for ln, then it shift will be E. So there's a button ln. So type ln 3.77 into 10 to the power minus 3. This will give you the value for ln k, which is minus 5.58. Then we have to plot a graph. As you can see here, the equation is given to you, Arrhenius equation. So you have to plot a graph from the values, but you can see the value of ln k is negative. So when it is negative, like, and you have the value from minus 5.58 to 9. So when you plot the graph in the same manner, you will plot this graph. Like we have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and so on till minus 9. And what will be the shape of this graph? The shape of the graph will be like this. And the gradient will be equal to minus E over R. So when you multiply negative gradient multiplied by R, what you get? You will get the activation energy. Is it clear?
Yes, sir.
So basically the major distribution of the mark is for plotting a graph and finding the gradient. Another question. So we have BrO3 with a charge minus 3. Overall reaction is given, the data is also given, and they're asking this reaction is first order with respect to BrO3, state with reason and appropriate experiment number in order,
So the same way,
the
this
same way
comparison.
a
Yeah.
comparison will be there. So you can, which two you can compare, because we want to show with a reason that it is first order with respect to BrO3. So how we can work out always, but as you can see, some of the like all the experiments, it is not same here. Like the concentrations are not same. It is, and it's a 5 marks. So how to work out this? First, the order of the reaction with respect to high, they already provide it is first order with respect to BrO3 with the charge minus. So if this is 3 times, the rate will be multiplied by 3, because as I mentioned, it is first order with respect to BRO3. So 1.68 exponent minus 5 multiplied by 3, that will be 5.04. So due to the change in value, it should be 5.04 into 10 to the power minus 3. Is it clear till now?
Yes, sir.
Then we
And
want
I
to
think it's -5, the power.
minus 5, not minus 5. Minus 5. Then what happened if we want to check even for hydrogen ion, we can check it directly. How we can check directly? Because the first question I was solving actually for the second one, like we are bromide ion, but in the first part they're asking for hydrogen. So here the concentration does not change, and here concentration is double. If concentration is double, what happened to rate? How we can work out if 6.72 divided by 1.68, you can identify that it becomes 4 times, because this is a value 4 times. So if
So second
concentration,
order.
it is second order with respect to hydrogen ion. And for bromide ion, how we can work out? So we'll mention, compare experiment 1 with experiment 2. The concentration of hydrogen ion is double, the rate is 4 times, so it means it is second order. Now you compare experiment 1 with experiment 3. But what happened? This BRO3 is also triple. So if this is triple, first the rate should be 3 times because of change in concentration of Br. So if rate is 3 times, so 1.68 exponent minus 5 multiplied by 3, that is 5.04 into 10 to the power minus 5. So because of the change in BRO3, the rate should be 5.04 into 10 to the power minus 5. But what happened? The overall rate is 1.0 into 10 to the power minus 4. So it means if this is double, so what happened? 5.04 become double, because this is double of 5.04, which is 1.01 into 10 to the power minus 4. So it is first order with respect to bromide ion. Is it clear?
Yes, sir. It's clear.
Because as you can see, this rate first changes due to BRO3 ion, and then if the concentration of bromide ion is double, we find that the rate is also double, so it is first order with respect to bromide ion. Then we have to write a rate equation. So the rate will be equal to K times, they provide that it was first order with respect to BRO3. We found that it is second order with respect to hydrogen, and we work out it is first order with respect to bromide. So this will be the rate equation. Then use the data, calculate the value for rate constant. So after using like we have this rate equation, we will substitute the values. And for experiment 1, so all the concentration values are given, like this one, all the values are given. We substitute in the formula, and we'll get the value for K, and it should be an appropriate unit. Then what evidence suggests that this reaction produced by more than one step? So what is the evidence that this reaction might proceed in more than one step? Look, as you can see, there are a lot of particles, like 4 particles are there overall. When you check the equation, as we work out the rate equation, so as the number of the particle in the rate determining step and the overall equation does not match with each other, because overall equation you can see one particle of BRO, 5 particles of bromide, and 6 particles. So total 12 particles are there, and it is unlikely that 12 particles collide at once. So that's also confirmed, like lot of particles in the original equation which unlikely can collide at all at once. That's why it will have a multiple step. Or you can also say that the rate equation and rate determining step or rate equation is different from overall equation. So this also confirmed that the reaction might proceed in multiple steps. The initial rate of reaction was obtained, measured the concentration of bromide. How the initial rate of formation of bromide calculated from concentration time graph?
By drawing a tangent, then the
Yeah,
gradient.
that's good. So we'll draw a tangent and find the gradient, and that will give us the initial rate. So sketch a graph for concentration time and draw the tangent. So this was the structure question related to topic rate and order of the reaction. Any question related to the class? Any question or a doubt?
Sir, it's clear.
Okay, so I'll end the session and share this with you along with the assignment. So you can solve the questions
So I
now
have
by
to solve all of this.
yeah.
Okay.